Today we have a geometry problem. The question we are asking is the length of the red line greater than the length or the sum of the length of the green arcs? As you can see, the red is actually a semicircle, and we have three green semicircles which are inscribed inside the bigger red semicircle. You can pause the video to try to solve the problem. Before we look into the individual components of red arcs and the green arcs, we can look at the general formula of the circumference of the circle. It states that the circumference of a circle is 2 pi r, or in other words, we can write it as 2 into r is nothing but pi diameter. So let's assume the entire distance is diameter, which is represented by d. Since the red is a half circle or a semicircle, we can write the perimeter of the red arc is nothing but the total circumference of the circle divided by 2. Or in this case, we can just extend this into a big circle, as you can see, right? Okay. Now let's look into the green semicircles. So for green semicircles, I'm going to start defining the lengths of it. Okay, so for this semicircle, let's take this length to be d1, and let's call this one as circle 1. Call it a circle 1, right? So let's look into the circle 1 of it. So again, we can write this as the green of circle 1 is equal to pi by 2 into d1. Applying the same formula over here, so we have d2, right? We have c2 is nothing but pi by 2 into d2, and c3 is nothing but pi by 3 into d3. Now the entire length of this green arcs is nothing but we need to sum c1 plus c2 plus c3. So we have the length of the green arcs is c1 plus c2 plus c3, which gives us pi by 2 into d1 plus pi by 2 into d2 plus pi by 2. I'm sorry, this should be 2. Pi by 2 into d3. So here pi by 2 is the common factors. We can do this pi by 2 into d1 plus d2 plus d3. This is nothing but pi by 2 into d1 plus d2 plus d3 is nothing but d. So we can write as d, and if you look closely, based on this equation, we have red circle is given by pi d by 2, and here we have pi d by 2, and we can replace this as nothing but the length of the red arc, right? So The general concept here is we were able to solve this problem using the circumference of a circle. But the interesting point here is, the length of the green is equal to the length of the red arc. You can generalize this theory further, as let's say we have a big circle, and we can have n number of small semicircle inside it. It can be even like 200 or even 1000 semicircles which has been inside this red circle. The length of these arcs will be always equal to the length of the bigger arc. Hope you found this problem interesting. Thank you for watching. Have a good time.